we got cut off for the last part. So this is where it left off, that we had 2 moles of ammonia times the negative 45.9 kilojoules per mole plus 4 moles of water times the energy formation associated with that, which is negative 242 kilojoules per mole. And now I'm going to subtract from that the energy of formation of all of my reactants, right? So I'm going to add all these things together. So my 2 moles of my NO2 times the energy of formation associated with that, which is 33.2 kilojoules per mole, plus 7 moles from my hydrogen times the energy associated with forming hydrogen. Now remember, the energy associated with forming something that's in its natural elemental state is 0. It doesn't take any energy to form that, it's already made, right? So 7 moles times 0 kilojoules per mole. So obviously this is going to go to 0, and I'm left with 3 separate substances. I'm going to go ahead and write down the numbers that are associated with those, okay? So the energy associated with this one is negative 91.8 kilojoules. And then the energy associated with my water is negative 968 kilojoules. And the energy associated with this is actually a positive, but I am going to subtract it. But it is positive 66.4 kilojoules. So the change in enthalpy for this reaction is negative 91.8 kilojoules plus a negative 968 kilojoules minus 66.4 kilojoules. Okay, so when I do that math, I get negative 1,126 kilojoules. So what kind of reaction do I have? It's negative. It's an exothermic reaction, so I'm going to list this. Oops, we fell over. We're going to list this on the product side. So I've got 1,126 kilojoules of energy associated with this reaction. Now, that's just the first step, right? Because that tells me how much energy I'm having, but now they've actually given me an amount of ammonia, and they want to find out what's the energy associated with that particular amount. So of course, now I've got to move back into stoichiometry. So I know that 35.0 grams of NH3 is going to be, so for every, to get 1 mole of NH3, I've got to have 17.0 grams. And when I do this, I get 0.06 moles. Now before we jump right into stoichiometry, I want to notice one thing, okay? We've got 2.06 moles of NH3. In the chemical reaction, for every 2 moles, here's my stoichiometric relationship. For every 2 moles of NH3 that are produced, I will release 1,126 kilojoules of energy into the surroundings, okay? So I've got not 2, but something very close to 2. So hopefully, when I finish this problem, I should get an answer that is relatively close to the 1,126 kilojoules of energy. So let's go ahead and figure that out. 2.06 moles of NH3. For every 2 moles of NH3, I'm going to release 1,126 kilojoules. When I do all this work, I come up with a number that is 1,160 kilojoules of energy. Okay? And that is the answer to problem number 5.